Hello. How is everyone today? Good? All right. So I'm going to be talking about the architecture of components and managing complexity without a state management solution. You can reach me on Twitter, Erin Coughlan 16, or the bit.ly link is arccomponents AC19 for this talk and presentation. So we had this in the introduction, but I work at Google. I'm a software engineer on Google Marketing Platform. This is it's a parent of many analytics products. So we have Google Analytics, Google Tag Manager, Google Optimize, and this is really like the root of all of those. I call myself a component architect too, because I love building components, and I like this whole entire of how you build an application start to finish. So I'm going to jump back a few months to when we were figuring out this talk. I'm sitting in this micro kitchen, what we call them, but it's basically just a little cafe, with one of my friends, David. And we're talking about NgRx and Angular and state management basically as a whole. And we don't agree on anything. He loves NgRx. He's using it for his brand new application from the ground up. I, for my team, have other concerns with my team doesn't know Angular, they don't know AngularJS, we don't know RxJS, so let's throw a fourth one in there? Maybe not. So what we did, we kept talking, and what we came out with was actually the content of this presentation. So it is not whether you should or should not use NgRx. That's for every single person in this room to determine for their own team if it is right for them. There's tons of talks on pros and cons. Go check those out. It's also not a way to avoid state altogether. We're here because we have state. We're not writing static HTML pages. If we were, I don't know why we're using Angular. Maybe I shouldn't say that, but yeah. What we will talk about are the types of components and where state should live. So first type of components. There's three types of components. The first two are presentational and container components. These are a lot more familiar, smart and dumb. Third one is layout components. I'm going to go into each of these a little bit more in depth, but layout components is more of a new one I don't see as much, but it's like the layout of your page. So for presentational components, these are also known as dumb components. I will probably use that a lot, so just know that these are the presentational. I don't know, dumb sounds cooler to me. It's stateless, and it uses inputs and outputs for communication. So you send in values, it renders something, it emits an event when it's done, and some other one manages the state and makes all the updates. And one of the really cool things about these presentational components is that it's way easier to test. You don't need to make fake services, you don't need to make a fake backend or make any actual calls. You pass in inputs, you check that it did something correct, and the right output is emitted. Next are the container components. These are the smart ones. That's totally not a brain, but you can pretend it's a brain. Think of it as like the brain of the operation, all these little things coming out and organizing your application. It connects these presentational components to the state in your application. And it handles these emitted events. So the presentational one emits an event. I then respond to that event. I make a call to the server. I update the UI. I'm really the brains, I'm the one controlling everything. And these layout components. The screenshot over there is actually from Google Slides, but it's a layout of the way your page looks. For this one, you don't really have data. You don't need to update this when it changes. It's just different pages. So as an example, this is medium. There's 3 different panels here. You can think of a layout as right, center, left. And clicker doesn't work. OK, I don't know why that worked. So the container is the top. It's the brain. Layout is next level, is how you split it up. And presentational is this bottom level of what actually gets rendered. So let's talk a little bit about data. How do we get the data into all of these components? I mentioned input and output between the container and these presentational ones. But then where does the data come from? We have something like HTTP client, NgRx, NgXS. Maybe it's your route. These all go into the container. So you take all of these different sources at the top, throw them into your container. It does whatever it needs to do with the state, passes it to stuff that actually renders it. So really here, we're trying to separate out these two different behaviors. We have the one responsible for rendering it, and the one that's actually responsible for organizing your data. And with that, I want to say there's a little warning here. So if you have an input that only exists to pass it to another input a level down, maybe it's not the right abstraction. So an example of this, just to make it more clear, is favorites. Okay, this really white component is called the universal picker. It allows you to navigate between all Google Marketing Platform products, so Google Analytics, Google Tag Manager, and you can search for anything you want. Customers loved this thing. We launched it probably 2 years ago. It was pretty awesome. But we missed one thing at the beginning, that little tiny star. So we have to add this star. Like, we don't want our customers mad. We're gonna add this star, we're gonna prioritize it. But let's see how we actually architected this the first time and why this passing properties down may not have worked. So we have 4 main sections here. The top is a tab bar, and you can think of this as the Angular material tab bar. Another one is the next level with the products. It's also a tab bar. It's just icons instead of text. Over on the side where it says Erin's organization, that is a drop-down. I click on it, I can switch organizations. And these 3 list views is another one. We put each of those into their own component. All the data is in this main universal picker, and the 4 other components, they just take an input, they emit something when it's out. But the code was a little complicated for that list view. There's 3 columns in there. It's more or less the same content. So we went a step farther. We split the 3 into 2. So now we have 1 component, universal picker, to the list, to a column. And we further split that up because the rows are just repeated a bunch of times into a bunch of rows. Now remember that little star. We need that star to have a value from our server. So like a feature flag, whether it's on or off. We're not gonna just turn this on. We wanna go over like a week or so and roll it out. With this design, we had to pipe that value, the feature flag, down my list, to my column, to my row, to the star, which was the component in the row. Yeah, that's a good face, Ward. He looks very unhappy with this. And we were too. It was very complex and hard to reason about where the data should go in here. So, yeah, there you go. That's another face. So very, very unhappy, mind explosion. Be careful here. But fortunately, we got to rewrite this. So favorites v2. Well, first, what went well? We had small reusable components. That drop-down was great. The little tab bars were great. And even though we broke it down into a single row, it had a single functionality. Single functionality. Second, we had this one smart component with all of our data. It was all orchestrated inside this universal picker, and we later could pass it through to the other ones. So those things were good. What didn't go well was we had components with no purpose. That column was just a repeat over items. In every field that we needed in the item, we had to pass through the column. So it had no purpose but to send data further down. Not so good. And it was hard to reason about. It was something I could not assign to a new engineer on the team who had no background in how we designed this. Like, they would have no idea what we were doing. They're like, why do I have to update 6 files to add a stupid star? It wasn't stupid, but it was difficult. So we wrote it again. For the next version, we got rid of that column in the row. So we have our 4 dumb components. We have the 2 tab bars. We're using Angular material, so a lot of that functionality we don't have to care about anymore. Our drop-down, and then all 3 columns is a single dumb component, single presentational component. But it's not super straightforward because we still have the star. What we did with the star was we wanted this to be used in multiple places. And this is some of the decisions that you would go through when you're trying to decide whether to have a dumb component or a presentational one. We wanted that star to be reusable. We wanted to be able to put it anywhere on the page, not just in this component. I wanted to have a field, I want to click on it, I send data to the server, it updates. We wanted that type of information on it. So it didn't make sense for this entire universal picker to be controlling it directly. What we ended up doing was a little bit with services. I'm going to talk about the Angular service a little bit later, but we actually made the star itself smart. So where should your state live? First, why do we need state? Some of this goes without saying, but it's really this interface between your data and your components. You have a server, it has value, you have maybe a route, it has data, and somehow you have to get that to the thing that renders on the page. You need data from somewhere. And your state is that that communication between both of them. It also allows you to keep data consistent between the components. So if two components need to rely on some similar data, you can use a state to keep them in sync. And thirdly, it allows you to perform communication between the two of them. If you think of a service, you call update, other components actually update within it. So there's a few different types of state. You can actually break this down further, but the three I like to think about is really the server, the application, and your page. The server is data in the back end. You get it through either HTTP client or some other URL fetcher that you have. The application state is the things that persist across all of your applications. So in ours, we have this thing called an organization, and every single page in my application needs to know what organization I'm in. Maybe another is like a user if you have some kind of multi-login, or maybe an account ID. You want to know what account you're in throughout the entire journey. Finally is this page-specific state, something only needed on a single page. Think of maybe a form or something. You don't need the form data outside of the form itself. So how do you know which state to use, and how do you know where to put that data? There's two questions I like to ask myself. The first is, how many pages does the state affect? So is this a single page? Is this your entire application? And secondly, it's how long should the data last? Does it need to persist across sessions? Is it a single session? Is it in that form that I mentioned? Is it only in that form? Is it only on a page? And how long should you retain that data for? And like everything, there's a lot of options for how to do this. First, there are Angular services. I'm going to show an example of that right after this. Next are those state management libraries, NgRx, NgXS, several others. All are state management libraries. We're not going to get into that one, but that's another way you can store and manage the state. Next is the router. So for those states that have to live across sessions, putting some information in the router will allow you to send the URL to someone else. They can open it up and actually see the exact same thing you're seeing. So that's another way to store state. And finally, within a single component. So think of the classical to-do app. You have an array, and inside there is a list of to-dos. And that's all within a single component, in a single smart component. So some examples to make this a little bit more concrete. So Angular service. We have this thing called an organization. Organizations are everywhere in our code. They have an ID, they have a name, they have a logo. It's a fairly simple object, but how do we actually get this data? We created something called sweet context service. We say it's provided in root, so it's a singleton across all of our application. I inject it, and it's the same actual instance. And we create a subject. So this is private. We don't expose this to any of our end users or any of our applications. So we have a replay subject that always will remember your previous organization. What we do expose, however, is the observable. So we take the observable part out, and we expose that. Anyone can subscribe to it, then they immediately will get the current organization. And when I need to update that current organization, such as in my dropdown, I can then call into this service, call setCurrentOrganization, and by that subject next, anywhere in my application that's subscribed to it, and actually later subscribe to it because of the replay, will have the exact same organization. So this is keeping my state consistent across the entire application. Whenever it gets updated, we update this service, and everyone has the correct value. So the next one is router. And this is also, we're going to use organization again. That's what my app does. So the router here stores the persistent state. So stuff that has to exist every single session you go into it. It also allows users to share pages with other ones and actually end up in the same spot. So here's an example from our application. I have home. This is my first route. It's basically the entire container of the page. It's what renders the header on there. And the actual content of it is a child, which is this orgs. This really long string is my organization ID, and that is the current state that I am in. So I am in organization CBT, blah, blah, blah. So you can think of this as this org ID. I have some kind of parameter, and it is org ID. The final piece is settings. So this is actually the content of the page. I am looking at the settings of these organizations. So the route kind of cascades down, and in there, we're actually encoding some information that we want to use. Final is a query param. Auth user 0 is actually just the current user. So our applications support multiple users. And so if you have 4 users, you have user 0, 1, 2, and 3. But that's in the URL for all of ours. So when you log in, I know who it is. Probably don't share that part, because you'll end up in the wrong person, but that's in here as well. So how do we get that value? So here I have my smart component. And what I do is I inject the route of this component. So I have something, inject the activated route, and then I inject an organization service, which is my HTTP service to fetch data from my backend. I create a read-only observable, and actually read-only observable of this organization. So I want to be listening to any updates in it, and I want my actual UI to get updated with it. So on the activated route, there is a list of all the parameters. It's param map. It is also an observable. So we can pipe and get the org ID off of this map. So I now have the current org ID, that long string that I used. And what I do with this is I send it off to my server, and I get the value back. So here I'm setting up this whole entire chain of getting data from the router and taking that information, sending it to my server, getting the data back, and now I have all of the information about my ID, my logo, and the name of my organization. So this type of pattern here, where you're resolving these different params and then actually updating the UI accordingly, it helps keep it in sync. I change the org ID in the URL, this gets updated, and my UI switches to a different org. If you actually want to put this everywhere, you can use a route resolve instead. I don't go into details here, but that's just getting some of your data earlier. So favorites v2, I told you this was coming back. So we have our star, and we have our setup here with the 4 different dumb components in that very smart star. So we pass in, there's a single input. We pass in the ID of the account or that little entity into our star. So that's the only value we have. We need to know which of the rows in the list is the star related to. The universal picker gets data from the route. I showed you the current org on here, where we're getting our current org ID and getting the data. We also have account IDs oftentimes coded in there, so whatever current account you're in, those are all coming from our route. And with that, we can list all of the accounts from the server and really combine this data. So we're taking our server data with the list of accounts, putting a checked value, which is a Boolean of current, essentially, on it, and then rendering all these stars. When the universal picker gets this data, we also can set the stars. So we don't have an easy way to get a star for a single account. Or rather, we do have a way, but if I have to make that call 10,000 times because you have 10,000 accounts, it's a lot slower. So this list one actually is filling out all of the information, and because we're getting all the accounts, we just add an extra field in there for that state. We go ahead and set the stars in this star service. So the star service is now a smarter Angular service, and it's keeping track of a map of every single star to their true-false value of true and false, or their Boolean value of true and false. And our star component can look up the value of a single star based on that ID, and when it's updated, we actually go ahead and update the star service, and our map in that service now has a new value, and our component is updated. And it helps keep these two things in sync. The star service has it's like last modified time, so we use that to actually invalidate some of the other data from our list. So we know we have an update past when we initially fetched it, and we can invalidate that and fetch new data. So this is kind of how it's all set up. The star component actually is doing a lot here, and the universal picker is doing a lot. We're skipping all those I skipped the drop down because that actually is truly dumb, but these are how the smart ones interact. So let's look at how to bring this together and summarize what we've learned. How do we architect a web page? First, it's always look at the requirements. We want code to be simple. I want to be able to give it to some engineer who's maybe new to the team or less familiar and have them actually understand how we set it up. So making the code simpler. We want it to be easy to maintain. I don't want this code breaking every week because some weird connection between some component and another component just didn't work and then it broke. We also want to do things faster. So we want to be able to launch features as fast as possible. And the better architecture we can have and the more upfront planning we can have about where the data lies, how we're fetching data, and how it's then delegated to components makes that happen. So let's think of the principles we've talked about. First, we want to reduce the application-wide state. And this is really thinking about where the state should live. You're not going to put every single object, an array, or anything any component needs and expose it to all the other components. So you want to scope it to the section of the app that needs it. I used the form earlier as an example. If only the form needs the state, there's no reason some other page in your application also needs that value. So you can scope it to the correct location. And third, we want to separate out the container components from the presentational components. We want to upfront decide what needs to be smart, what needs to be dumb, and what trade-offs we're making. We saw with that star, I made a trade-off in switching it to be a smart component as opposed to a dumb one, and what those trade-offs mean for your team. And with that, I want to say thank you for listening. I will be around in the expert zone tomorrow at 1:25. Thanks.